Take it away, Wido.
Okay. Good afternoon, everybody. I'm going to be talking about a pretty boring thing because it's out of band. And we just had a talk about scaling to 100,000 hosts, and now there's somebody talking about out of band, which is not sexy, right? So, well, we always need to start with this slide, right? Who am I? And, well, Dan already said, I'm a committer PMC member for, I think, 13 years now, 12, 13. Well, it wasn't an Apache project by then, but I've been working with CloudStack since 2011. This part of the screen is a bit more difficult to see, but I'm CTO at Your Online. I have a short slide about that. Open source committer, work a lot with Ceph, and I'm an IPv6 fanatic, which you will see during this presentation. So, who and what is Your Online? We are a aggregation of hosting companies. We're an M&A serial acquirer, so we acquire hosting companies within Europe, and we started in the US. We currently have 52 companies which we acquired, and we are still acquiring companies. And some of those companies, like the one mentioned here, Axarnet here in Spain, and Your Hosting in Netherlands, they are using CloudStack in production. So, we have two large deployments of CloudStack in Amsterdam, in the Netherlands, and in Spain, here in Valencia, and we have more deployments coming in 2025. So I want to talk about out of band, and I'll be talking about out of band for a pretty long time, and then we'll switch to CloudStack, and there's a reason behind it. So, you know, what is an out of band network? Who has an out of band network in their data center? I see a few hands. Okay. So, it is a separate network which you have in addition to your primary network so that you're able to connect to your devices, which are your switches, your hypervisors, if something goes wrong. Because we always say, well, we'll never go wrong, but there will always be a moment when your primary network is down or under stress. So DDoS attacks or fibers being cut or you made a misconfiguration. So these doomsday pictures, they do happen for network operators, and they always happen at the worst moment in time. They always happen at Sunday morning at 3 or something, or when you want to go out to a restaurant and then you get a call at Friday at 6 saying, you need to stay because there's something broken. Huh? So it isn't it Murphy's Law, because anything that can go wrong will go wrong. So that's why you want an out-of-band network. And I'm going to be talking a bit about how we designed our out-of-band network and how we're using it in our environment. So, but before we get to that, I'll start with the data center layout, because I think it is essential to understand how we set up the data center racks and then how out-of-band actually fits into that environment. So if you look at our environment, we have 2 network racks per data center, and then there are racks which are either allocated to hypervisors or they are allocated to Ceph storage. So we'll have as many hypervisor racks as needed and as many Ceph storage racks as needed. And we can just keep adding and keep scaling up into 100,000 hosts now, so that's quite a lot of racks in a data center to run as hypervisors for CloudStack. And there's a few things which have a dedicated role: network aggregation, hypervisors, Ceph storage, or we're also using TrueNAS NFS storage. So there might be an additional rack which is providing TrueNAS storage. And if you look at a hypervisor rack, this is how it might look like. And I actually don't know if this is from Valencia or Amsterdam, but this is a picture. I guess it's Amsterdam. And there's a big arrow pointing there. So I'll move out of the way here. So it only contains one type of hypervisor. So either Dell or Supermicro, and then a specific type of them, 2 top-of-rack routers using 2 times 100 gigs going out, and there's an out-of-band switch in there. And notice how this switch is there, and the cables are connected on specific ports on out-of-band switch. We're not starting at port number 1. We're starting at specific ports in those racks. And the same would be if you look to a Ceph rack. There will be an out-of-band switch where the devices are connected. So 3 monitors, and then we add additional OSD machines. So if we would look at a table-wise patch panel, 2 switches, an out-of-band switch, and then we get more devices. We're actually having 1 U space between all the devices because of airflow, and these hypervisors with the terabyte of memory, they're consuming so much power, they're getting pretty warm hotspots, so you need to move them over the racks. So the naming of these devices, so HV, hypervisor, 138, that's actually the room 138 in a specific data center, rack A05, and then data center AMS06. So we say, okay, this is data center AMS06, so based on the host name, you see of the device, you know which rack in which data center, in which room, and on which unit you will find this device. It's very easy to locate, no need to do administration, you find it based on the host names. Same goes for the Ceph racks. Again, top of rack, out of band, monitors, OSDs, and their naming, and then the role, mon, OSD, and then the host name as a suffix. But why out of band, and how did we build the out of band? Because you see the switches are in there, and I see a lot of the out of band networks, they are treated as an afterthought. Yeah, we have it, and we'll spin up the VPN when needed, but then people figure out, it doesn't work, I forgot to configure this, I cannot reach the device, I'll jump in the car to the data center because that's quicker before I can fix this out-of-band network. But we treat out-of-band as a first-class citizen. It should work all the time, everything should go through out-of-band, and we use it for daily operations. So looking at our environment, how we built our out-of-band, it is a dedicated layer 3 network in those data centers. So there's an internet connection, there's an out-of-band site router, which is doing stateful firewalling. But as you notice, it is announcing a IPv6 subnet. Our out-of-band is completely IPv6 only. It's v6 first. And what we do, we announce a 48, and I assume everybody here can calculate jitters and those subnet sizes, but 48 is bigger than 64, which is down there. So from the 48, we have an aggregation switch in the data center which receives tagged VLANs from the site router, and then each rack has its own individual VLAN for its out-of-band. And each rack has a /64 allocated and a 24 v4 for some legacy purposes still there. So based on the v6 address, you know in which specific rack you'll find the device. So we're using the IP address and identifier to locate the device as well. So there can be no debate. If you see the address, you know which rack it is. And some might say, yeah, but it's v6, that's scary. I'll get to that point at a later stage. So looking at the MikroTik router, it will be announcing to its peer a 48. It's announcing a v6 subnet. I've taken this from a production environment. It is announcing some addresses to the public internet. And as I said, there's a v4, but we're not spanning any layer 2 over different racks, so no spanning tree. Often you see that out of band is one big VLAN for the whole data center. Again, it's not treated as a first-class citizen. People are just using it as an afterthought. You should not be spanning layer 2 over too many racks. Now, looking at a picture here from Valencia, I've taken this as an example. So there's an aggregate of 48. We're also using a v4 local, which is a 19. And then you'll see rack 1, VLAN 3001. It has a 64 and a v4 in there. Again, based on the address, you know in which rack the device will be. But what gets interesting with v6 is that if you're looking at the MikroTik router, you say, oh, I want to know the neighbor with the MAC address, which ends at 2A. If you look at v6, how it does address allocation, in this case, a device obtains an IPv6 address based on its MAC address. So we have the prefix, the 64, the MAC address, and then there's a RFC, 4862, you can find the RFC. Based on the address, it will just generate a v6 address, and that's the address it will have. So there's no need for address administration. You know the MAC address. Even if you look at the stickers at the back of a Dell Supermicro, it says, I think, OOB MAC address. The MAC address is printed on the physical device. So any engineer can just write a script and generate this address. That's the address the device will have. So using what they call stateless auto configuration, stateless address auto configuration in v6, the devices generate their own v6 address. And these devices are the IPMI or IDRAC of your device, or it could be a PDU in the rack which is connected there. So if I would go back to this picture here, and these PDUs, they are also connected to the out-of-band, and they have IPv6 enabled, and they'll just generate a v6 address based on their MAC address, and they are now reachable. And the only one which we have to configure statically is the v6 address for the out-of-band switch itself. It has a single VLAN, nothing else, just VLAN 1 on there. It obtains, in this case, it's a Juniper device. It has a address set, but look at the host name again. The host name ends at 41. the IPv6 address, the device is allocated, uses 41 at the end. So again, it corresponds to the unit number where the device is in the rack. And then all the interfaces are in the same VLAN, and you can now suddenly reach this out-of-band switch via v6. But as I said, everybody thinks that v6 is scary, that it's open to the internet. Well, there's a stateful firewall in the middle. So there's, in this case, a MikroTik router, which blocks all inbound traffic, except for certain ICMP traffic. But if you want to connect to TCP on these devices, you will need to come from a specific address list before you're allowed to connect to these devices. And don't forget, of course, there's also authentication on the devices themselves. So if you would get through the firewall, that would be a major security breach, where you would not be within the iDRAC or IPMI immediately, because there are passwords, of course, set on those. But the site router performs the stateful firewalling, and then TCP connections are only allowed from trusted networks. So that could be our VPN servers, monitoring servers, management servers, and ICMP is essential for v6. There is some filtering on there, but often it's best practice to just let ICMP v6 go through. You could apply rate limiting, but I wouldn't do too much. Otherwise, you need to dive into RFCs to actually know which package you need to allow. But management is done via SSH, so switches are managed via SSH, or the iDRAC and an IPMI support HTTPS. So if you want to connect to one of these devices, you could use a management sitter. And what we did, we allocated a /40, which is bigger again than a 48. And that 40, we announced different 48s from the internet, from different locations, how you could connect to them. But we only need to allow one single /40 in our access list. So there's one /40 allowed, and if you're getting from that 40, then you're allowed to go through and into these devices. And then the 48 is the smallest subnet which is allowed on the internet to announce. So from different sites we can advertise a 48 and you can get in. But we have multiple 48s. So there's one for the VPN where employees can connect to, or some Bastion host using the proxy jump of OpenSSH, which is explained here. Maybe you know, maybe you don't. SSH-J, you can jump through a host to something in the back. So this picture shows if you want to go from the client to the server. The client can never reach the server, but you can SSH right through the jump host and get to the device behind it. Easy to get into a switch, so you don't need to SSH into a device and then SSH again. You just jump through immediately. There's another picture I found on Google. You cannot read it here, but our Bastion hosts, so that would be the jump host in the middle, they only accept SSH connections signed by a YubiKey. My YubiKey is in my back there. You can nowadays have private SSH keys where you have the private key and the YubiKey. And the private key can only be unlocked by using a YubiKey. So if somebody would steal your private key, it is worthless without having the physical device to unlock that key. An additional layer of security, because the problem with a passphrase on a private key is that often the passphrase is also kept somewhere in a vault, in a locker, and if that's stolen, then you suddenly have a private key which is working. And with the YubiKey, you physically need the device and press the button on the device to unlock the private key. Look at the how-to, which is on a blog, but OpenSSH now natively supports this. So the daily use would be that you have it's used for daily operations, so for SNMP monitoring and for SSH. And this is what I meant is where a lot of out-of-band networks are not used on a daily basis, or they're an afterthought. We use it on a daily basis. They're used all the time. So if the out-of-band goes down, we will know within a couple of minutes that it's no longer working. All the management and all the SSH, so the switches, their management VRF is connected to the out-of-band. All the IPMIs, iDRACs, monitoring, it's all going through them. But is it a lot of traffic? No. What is this? 8 megabits a second? Which is ridiculous, of course, right? We're always talking about 100 gigs, more, a lot of traffic, but it's not that much. But it's very vital traffic, that 8 megabits of traffic with SNMP and SSH information. But by using the out-of-band network for daily operations, you suddenly also experience that it's a very valuable network and you'll keep using it. But it's a completely separate layer 3 network of our primary network, in addition to the existing network. So Then you might say, I don't have v6 at work, at home, at my mobile, whatever, so this is not feasible for me. Well, what we did, there's as a VPN built with OpenVPN and pre-tunnel, where we route a 48 to the VPN, and then if you connect to this VPN, you'll get an address, and 128 allocated to you as a client, which is just a v6 address which works, but this address is actually from that larger 40, which then allows you to go through the stateful firewall and connect to the devices behind it. And that means that if you look at the network, there will be the internet with the primary L3 network, and then there's the out-of-band side router also connected to the internet, and the top-of-rack host, they're all connected to the out-of-band switch in that same network, which then goes out. So our management goes in via out-of-band, and all the primary traffic goes through here. If this goes down, no problem at all, everything still functions. These have a management VRF, this one has a management VRF. We can just go in for as normal. So it is normal procedure to go through the out-of-band network. It's not an exception on your daily work, it's just using it on a daily basis. That's mainly my advice. If you have such a network, use it on a daily basis so you always know it works when you need it, because you're using it for everything. So with CloudStack, how does out-of-band with CloudStack then work? Because we're at the CloudStack conference and I'm here talking about v6. How does it work with CloudStack? Where's the benefit with CloudStack? A few things you should know. So Supermicro calls it IPMI and Dell calls it iDRAC and HP calls it ILO, but there are two things. IPMI is something which was defined years ago by Intel, and it's called the intelligent. Well, you can read it yourself, but nowadays there's also Redfish. Who has heard of Redfish? More than I expected. I'm proud of you. Because, but Redfish is now the RESTful API where you can now manage a BMC, so the base management controller of a machine. And you see that all the bigger vendors are now supporting Redfish on their environments. And that's very interesting, because one of the most difficult things with doing HA is actually reliably determining if another host is down. So how do you do HA? You get two machines, or let's say you have 3 machines, 4, 10 machines, one machine is down. How do you define down? You don't know. It might be that it has a few problems. It might still be connected to storage, but no longer to the management server of CloudStack. So what CloudStack now supports is that you can shoot the other node in the head, where you can use the out-of-band functionality of the management server to reboot a hypervisor to really make sure that the device is down before HA kicks in. So KVM HA out-of-band fencing, and Rohit, help me here. This was 4.17, 4.18 when it is merged? Even before. It was a while ago when this was merged. But the whole idea is that you can configure out-of-band management if you're on the host tab. And if you configure that, then you can say turn on the host, turn off the host, cycle the host, whatever, all those actions. And CloudStack can also do this now. So that means that if it wants to do HA on a device, making sure it reliably fences the machine, it can send a reboot command to the BMC. The BMC will just reboot the main board, everything, so you know for sure that the workloads on that machine are offline, and then CloudStack can safely start the instances on a different hypervisor without risking a situation where an instance might be running twice on different machines. Whoever experienced this, that they had a VM running, and yeah, the data corruption is hell, right, if that happens. If it only happens for a few seconds, the disk is ruined of that VM. It can take you hours and hours and hours to repair. And as I said, it's still a challenge with HA, reliably determining if the host is truly down before you initiate an HA. And configuring this in CloudStack, when you click on Configure Out-of-Band Management, you can provide the address, which can be an IP address or a host name, port, credentials, and then you can choose the driver, which can be IPMI tool, which will be forked in the background, or Redfish, which is a native API client inside the CloudStack management server, which will do the call towards the HTTP. There's a few settings here. I hope you can read it, but you can say that should it ignore the SSL certificate? Should it use SSL for the Redfish communication? A few things you can enhance security for Redfish. I would recommend using Redfish over IPMI. But of course, what you need to make sure is that the management server is allowed to connect to the BMC address of the host. So in our case, the management server has a v6 address, and then the firewall on the MikroTik allows the management server connected to the out-of-band network and execute a power cycle. And this is a pretty easy way, because what you can also do as an admin without needing to go to the host itself, just go to CloudStack, click on the host, click on power cycle, and then the management server will just power cycle the host for you. So CloudStack is your single pane where you can now control your hosts. And Dan, I'm pretty good on time because we're almost there and we still have like 9 minutes left. So it's an addition, and that is why I wanted to start with saying why an out-of-band network is really important, and then shift to CloudStack. Because if you want to enable this functionality within CloudStack, you need to make sure you have a well-thought out-of-band network which operates properly, which functions properly, before you start enabling this functionality within CloudStack. I think it's a very powerful functionality to use, and it makes your environment more reliable, but I would say I advise you start with a good out-of-band network at first before doing this. And is it difficult building such an out-of-band network? No. A MikroTik router, difficult and expensive, few €100, then some switches. It's not very expensive. You just need to run cables to all the racks and do some address allocation. We're not talking about tens of thousands of euros or dollars of building such a network, because it's a very low utilized network, but very important. So that was mainly my thing, but my summary here is it's more than just a backup, your out-of-band network. I think I repeated myself a couple of times. Use it for your daily tasks, so with SNMP, but this SNMP server can be somewhere else. It could be, we're using LibreNMS. It just has an address which you whitelist in the firewall that it can go through and do SNMP queries, and then query your top-of-rack devices, your out-of-band devices. Our case, the PDUs can also be monitored by SNMP, and then you get the voltages and the power consumption, everything in there. And I say V6 makes your life a lot easier because it's directly routable, and I hate NAT. I think it's one of the worst things on the internet, but that's, I see somebody there, yeah, okay, you agree with me. NAT really broke the internet. I know a lot of people are used to it, and I can have a long discussion about V6 versus V4, but I hate NAT. Oh, it's horrible. But use firewalls to protect your network from any unauthorized traffic, and then reliably fence your host within CloudStack. So my main message, start building out-of-band networks. Next year I'll talk to you again, and everybody says, yeah, I built an out-of-band network, super cool. Thank you for giving me tips. If you want any of the configs or something else, there's also a blog post which somebody who worked with us built an out-of-band network, built it and made a blog post. If you want some configs or some tips, there's my email address. I can share this with you, and hopefully we can make the world a bit more reliable and have your HA working better. Because you will get a DDoS attack, which you didn't expect, at some point, or somebody cuts through a fiber. It will happen at some point, I promise you. Okay, thank you.